So yesterday I've done some of the NAT concept. So I think my screen is visiting. Oh, what's the public folder? So NAT is something like which convert public IP to private IP and private IP to public IP. Okay. So this one. Hello.
Sir?
Okay. So can you unmute? See, this is what we called. This is what we call local. Local. That is private IP, right? Right. This is what we called private IP address, right? Hello. And this is what we called a public IP. Okay, this is a private and this is a public IP address. Okay, now I want to convert. Okay, here at the router end, it will be converted into public to private and private to public. That is what we called NAT. Okay, converting the public to private and private to public. For example, so this is a router R1 which is connected to switch. Okay, it's connected to switch. Okay, from switch I've connected to PCs. Okay, its network is 192.168.1.0/24. Okay, so here what will happen? So when it's going out of router to connect you to the internet, okay, here we use the public IP. Public IP. Okay, so this is what we are going to learn today. Okay, how it's going to convert to this one. There are three types of NAT. Okay, so when it comes to the NAT, we have three types. Okay, so one is static. Okay, we have static NAT. Just a minute. First one we have static NAT, where when you're connecting to the router R1, okay, using switch 1. For example, this was a 192.168.1.0/24. Here I'm connecting myself to the internet. Okay, from internet I'm connected to some server 8.8.8.8. So here let's take 1.2.3.0/24 I'm taking. Here it will take 1.1 and 1.2. Now in static net, what will happen when this 1.1 guy wants to connect it to this 8.8.8, his source address will be 1.1, destination will be 8.8.8.8. When it reaches the here router, it will automatically convert into some public IPs, so like 1.2.3.4, and my destination will be 8.8.8.8 and reaches the destination. Okay, so when it reaches this one and when it's coming back, okay, then the my IP address will be, source IP address will be 8.8.8.8. My destination will be 1.2.3.4 and reaches here. And from here, the source IP will be converted into a private IP, that is 1.1, 192.168.1.1, and my destination source IP will be 8.8.8 only, but this one will be 192.168.1.1. This is what the NAT will do. Got it? Okay, so now we'll do the first things, that is static NAT. Okay, when it comes to the static NAT, okay, we'll do the static NAT. Static NAT. Okay, so in this static NAT, what we are going to do here, we are going to map the NAT. Okay, we are going to map the NAT. Okay, but we are going to map to the this one. For example, so we are going to map. For example, this is a switch 1. Okay, this is connected to the router R1. This is connected to the router R2. From there, I connected to the server 8.8.8.8. Okay, when this private IP wants to go outside of the public IP, in the olden days, when the stat was introduced, it was assigned this one. For example, if I take here 192.168.1.0/24, 1.0/24 on this side, and here it's going to be 1.2.3.0/24 is they are going to map a single IP, that is 192.168.1.1 will be mapped to 1.2.3. Let's say 11, and by the way 192.168.1.2 is mapped to 1.2.3.12, and 192.168.1.3 is mapped to 1.2.3.13, like that. So 1.1, 1.2, 1.3. Okay, but so for example, when this guy wanted to reach this 8.8.8.8 network, okay, this source IP will be, my source IP will be 1.1, and my destination will be 8.8.8.8. Still switch. When it reaches the router, okay, when it reaches the router, it will automatically. So which is the IP which is connected to 1.1? Public IP. This is private IP. This is public IP. Which is the IP? Huh? Which is the IP which is mapped to the this one? That is 1.2.3.11, and my destination will be 8.8.8.8. So when it comes to this routers, it will automatically. This is what the static net. Here in the static net, what will happen? There we are manually assigning the public IP to the private IP each by one. Means it will be mapped to the each and every single pieces. We are going to map the each and every public IP to each and every private IPs. Okay. So once it reaches the 8.8.8.8, once the request come back, okay, here you will be having a source like 8.8.8, and the destination will be 1.2.3.11. Okay, once it reaches the R1, it will automatically go to the private IP. It will automatically assign to the private IP. That is, it is like 8.8.8 is my source. Destination will be, what is the IP matched to 1.2.3.11? That is 1.1. So 192.168.1.1. Okay, so we'll do one thing. We'll do the lab. Okay, let me do the lab. Okay, this is the this is the configuration what I done. Okay, see, this is what my inside. Okay, so this above inside the gigabyte interface 0/0, whatever the things it is all belong to private. So inside the interface we have all these things is a private. Just all the things is a private IP interface. Above here, this is a public. Okay, so let me map that one. Okay, so first thing first. Okay, so let me check whether this guy can able to ping to this guy. Is it possible? No, because this is private IP address and this is a public IP address. Only with the public IP, it will go through the NAT. Once the transaction is done, the public IP you have to go and reach the destination. So let me check with this one also. Oh, it's failed. Okay. So before sending the data here, I have to assign the default network here, default routing table I have to reach here, because I don't know for which one I have to reach. I don't know this guys is going to, I don't know these guys which one you are going to, whether they're going to ping the servers or something else. Okay. So what I'm going to do, I'm going to configure this one. Okay. So enable config t IP route 0.0.0.0 destinations the network subnet mask 0.0.0.0. Okay, so what is my next hop? 1.2.3.2. So 1.2.3.2. Enter. It's done. Okay, now what I have to do, I have to tell this router which one will be my inside interface, which will be my private and which will be my public. Okay, so what I'm going to do, I'm going to use, so let me give that one. So config t interface gigabyte ethernet 0/0 IP NAT inside. Sorry, inside. So I'm saying that this interface, whatever the IPs which belongs in this side, this is what we call NAT inside. That is the private IP. Okay, so IP NAT inside. And I have another interface, interface serial port, that is 0/0/0. I'm mentioning this as IP NAT outside. So this is the outside interface where which is going to connect it to the outer world. That is, it is the public. Okay, this is public and this is private. So I'm telling the router that these things are the interface gigabyte 0/0, which are the IPs which is comes under gigabyte 0. So this is all the public IPs, and these are all the interfaces which will come to serial port 0/0/0. It will be my private, sorry, public IP. Okay. So after that, so I have to map each and every pieces. I have to map an IP address. So let me take IP NAT inside source. Okay, sorry. You have to exit first. IP NAT inside source static. So what is my first PC IP address? It's gonna be so 192.168.1.1. Okay, so 192.168.1.1. Okay, I'm mapping of the IP address from here. It is 1.2.1.2.3.11. Okay, enter. So same thing I'm doing for 2. 1.2.3. Enter. The same thing I'm doing for third one. It is 3.3. Okay, enter. End. Okay, so it's done. Okay, now what I'm going to do, let me send a packet from here to here. Source to destination. Okay, it's failed. Let me send again. Yes, it's successful. Okay, so next, let me send from here to here. It's successful. So let me send from here to here. It's successful. It's okay. Let me check what are all the IPs, what are all the public IPs it is taken as of now. So config t, okay, sorry, and show IP NAT translation. See here. See, 192.168.1.1 was mapped to 191.2.3.11. Okay, here when it going outside this one. So statically, I have given 1.11. That is 3.11. For 192.168.1.2, I have assigned 1.2.3.12. So I'm manually assigning the each a public IP address to. This is okay. This is fine. So as I told you, so I'm mapping you one to one. So then what is the issue here? So what is the issue I can able to get here? The issue is, since I map to one connection here, one to one connection, I have to buy all these IPs. I have to buy all these IPs because I'm connecting all these IPs. I use it to connect the public, that is to internet. ISPs. Each IP I have to buy for an amount. For example, for every PC, every IP I have to use like 3,000 like that. Okay, and one more thing, what will happen? Imagine that here I have taken /24 and each IPs I have given that one. Next, in the future, what happens? This one, 192.168.0.0, 192.168.0.0, I want more PCs because here only 253 IPs I can able to assign, but I want more PCs now. Okay, then what I'm going to do? I'm going to change this to 172.16.0.0/16 like that. Now, what will happen? This side on public side. So on public side, I have 1.2.3.0/24. But on private side, I have 172.16.0.0/24. Sorry, /16 is there. So here I'm getting 65,536 IP. On this side, I'm getting only 256 IPs. But what will happen if I manually started assigning? Only 254 IPs from this side, and only for here 254 IPs can able to map NAT when it comes to the static. Okay. So what will happen? What about the remaining things? Remaining IPs cannot able to connect to the internet. To the internet. Only these IPs, only the IPs only connected. To overcome these disadvantages, okay, to overcome this disadvantages, we get into the concept called as dynamic NAT. So dynamic as NAT is nothing. It's same like DHCP. Okay, dynamic NAT is same. For example, if I'm taking on this side 192, for example, this is the switch, this is the PCs, this is the router, this is the second router, and frame there I'm connecting to the server. Here what happen if I'm taking 192.168.1.0/24 on this side, and here I'm going to create a IP pool. That is, we call it as public IP pool. Public IP pools. So I'm going to create a pool from 1.2.3.0/24 network. So 1.2.3.10 to 1.2.3.20. So total IPs I'll be having a 10 public IPs. So what will happen here? If this 192.168.1.1, 1.2, 1.3, if 1.1 request, if 1.1 want to connect to the internet, when it comes to the R1, it will check the unallocated pool. So 1.2.3. is available. So it will connect it to 1.2.3.10 and connect, and this IP will go to the destination like 8.8. Once it come back and the session is done, session is completed, this will go and sit in the 1.2.3.10 will be go and sit in the unallocated space. So if anyone in the future, anyone can come and want to assign this one, it is going to the same like DHCP guys. Okay, when any guy wants to reconnect it to this internet, when it come to the router will check its pool table. Okay, it is going to check his pool table. Okay, if any one of the IP is available in the pool table, it is going to send it to this private IP. Okay, if okay, and once the session is completed, means once it requests for example the web page like that, once the session is completed, this one will automatically allocated IP will go and sit in the unallocated IP automatically, so that some other guy who wants to request for the internet will access this one. This is what the dynamic. Got it, Prakash? Bhuvan.
Yes, sir.
Okay. So now let me do the lab here. Okay. So let me do the lab. Okay. Uh, okay. Okay. Let me open the lab. Okay. So this is the lab. Okay. So the first things first, the same thing you have to do it when you are doing the dynamic routing. So I have to enable here. See, it's not going to ping because there is no public IP to connect to the public server. So here the private IP wants to connect here, but it's not happening because here only the public IP is going outside. Okay. Sorry, private IP is going outside and it cannot be able to reach this one. Only the public IPs can able to. So I have to now map the dynamic. Okay. The first thing first. Okay. First I have to enable the enable config t IP root. I didn't give that one. 0.0.0.0 so 1.2.3. And so again config t. So I have to mention, see, same lab. Okay, I have saved work 3 times. Okay, to show you static, dynamic, and pat lab. Okay, the configuration is same. Okay, so again, so interface gigabyte Ethernet 0/0. Now I have to tell them that which one will be my private IP and which side will be my public IP to the router. So IP NAT inside. So again, interface serial port 0/0/0. Okay, IP NAT outside. Okay, exit. So now it's done. So but here the one thing I have to do extra means I have to permit access. I have to permit access to this. This is public, that is private network to reach the public IP. In the previous, what happened in the static, what happened, we automatically assign each one will automatically assign the public IP to a private IP like that. But here in a pool it is going to take. So I have to permit this network to access this one. So let's give, for example, so access list 1 permit 192.168.1.0 network. So you have to give wildcard. Wildcard I explained yesterday. Just check in the lab. Okay. 255. Enter. Okay. It's done. Now I have to create a pool and I have to add the pool. Okay. So NAT, IP NAT pool name. I have to give pool name. I'll give pool 1. Okay, so range, I have to give the IP ranges. Okay, it's like a DHCP, you have to give the IP ranges so that anyone will be allocated to the any requested private IP. So 1.2 dot, sorry, 2.3 dot, I'll take from 20. Okay, 20 to 30. 1.2.3.30. Okay, how to mention this net segment subnet mask, that is 255 dot 255 dot 255. Just a minute. 255.0 and enter. Okay, so it doesn't take properly. 220.3 mask. So forgot to do dot. Okay, it's fine. It's done. Okay. Next, I have to put that NAT IP NAT. Okay, inside source. Okay, list 1. So list 1 means I have to permit whatever this one. I have made permit to do this one. So everything is inside 1. Access list permit 1 inside permit 1. So I have to permit this 1 to connect to pool. What is that pool? The pool name will be pool 1. Enter. Exit. Okay. So now let me check whether it is going to connect to the internet. So will be failed. Second one will be successful. So again, successful. So again, it's successful. So let me go here and check. Show IP NAT translation. Enter. See here. For 192.168 1.1, it has taken 1.2.3.20. For 192.168 1.2, it's taken 1.2.3.21. For 192.168.1.3, it's taken 1.2.3.22. If anyone connected to if the fourth PC is connected, it will take 1.2.3.23. Okay. The same thing, it will up to range. I've given the range. Up to how many IP address will be connected? 20 to 30. That is 10 I only there. Okay. If you want, you can do it for 30 to 40 like that. So once you send a message, for example, see, once you send the message from here to here, okay, see here. So the message will go here, 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 and reaches the destination. Again, it will come back. Okay, it's successful. Once it's completed, okay, once the transaction is completed, whatever the allocated dynamic public IP will be there, right? It is automatically removed and it will be put it in the unallocated space. This is what the dynamic routing. Got it, guys? Each and every private IP address. So for three in the pack, that is pack. That is
Sir,
yeah. Tell me.
sir, usually in our office we are using dynamic only, right?
No, 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 no. We never using dynamic and static. To understand you guys, I go through static and dynamic. Okay.
Okay.
Now we are in the PAT only. In your home only, when you connect into the interface, we are using PAT only. That is port, okay, address translation. Port address translation. So what will happen in this port address translation means, imagine this is switch 1, which is connected to the PCs, and here, which is connected to the router R1, which is connected to the router R2, and which is connected to the server. It's like 8.8.8.8. It is 1.1, 1.2, 1.3. This belongs to inside, that is private. Here, I'm taking 1.2.3.0/24 network here. Okay. So what will happen here in the PAT means in the PAT, what will happen? It will automatically take the port number. Okay. For example, this 1.1 guy requested for HTTP. So what is my port number? What is the port number?
It's a 1.1, sir. But
No, no, no.
IP address.
No, no, no. Port number. What is the port number for HTTP?
HTTP is 43, right?
80.
880, sorry.
HTTP is 80. HTTPS is the 443. Okay.
443.
So when you request this one, here in the source IP, we have 1.1. Okay, 1.1 local port. It is going to take the local port. Local ports will be from the range of 55,000 to 65,000. I've already told you in what is port numbers and how the port will going to take in this one OSI model like that. Okay, it is going to take the local port. Okay, for like the 54368 like that. In the destination, it will be 8.8.8.8 : you are requesting for HTTP means 80 will be there. But when it comes to the router, it will automatically change to any one single IP. That is 1.2.3.1 : 5667 like that. And my destination will be 8.8.8.8 : 80 only. And reaches the destination. Once it reaches the destination, okay, it will reply back with the HTTP this one. So in that, what will have means here the source IP will be 8.8.8.8 : 80, and destination will be 1.2.3.3.1 : 5677. Same thing like till it reaches the router. Once it reaches the router, the source port will be same 8.8.8 and 80, and the destination will keep on. It will change to 192.168.1.1 : 56777. So what is happening here means I am going to purchase only a single IP 1.2.3.1. Okay, but I'm using the different ports, okay, to reach the destination. So what is happening here? In the static, we map it 1 to 1. Okay, it's not going to work because it's very costly. So each IP will cost me around 3,000 like this. Okay, in dynamic, we given the range. Okay, we given the range IP pool. We created the IP pool. But what happens if the pool goes down? all the pool IPs will be, for example, if I take 20 range, if the 21st guy wants to connect to the internet, it's not possible because all the 20 IP public IP address is already allocated. To overcome this one, we had a port numbers. We have different port numbers where we have 65,536 ports is there. So each and every, this is in this one, 1 to 1024 ports are, it's already assigned like port 80, 443, like that. 1024 to like 50,000 or 35,000 ports are already for use it for registered ports, means it is already given to the this one. For example, MySQL, they purchased the port number 1433, like that. Okay, and remaining are the local ports which is for the PCs. So from 50 from 50,000, from 35 to 40,000 to 65,000 are the local ports. Any when anyone requested this one, the local port is assigned. But the destination, if you request us for HTTP, 80 will be allocated. If you request for HTTPS, 443 will be allocated. If you request for the FTP file transfer protocol, 21 will be allocated. Okay. So now you see you check when these three pieces, for example. See here what happens previously. These three PCs are taking different IP address here. Correct, right? In static, I mapped one to one. In dynamic, I've given a pool. But here, when I ping these three PCs like that, it has to go through single IP. Okay, to reach the destination, but the port number will be different. Okay, let me do the configuration. Okay, so again, I'm making this as a master. So every time I have to give this one enable config IP root 0.0.0.0 space 0.0.0.0 space 1.2.2.3.2. Okay, it's done. Config T. So again, I have to mention which is be my public and which will be my inside and which will be my outside. Okay, INT interface gigabyte Ethernet 0/0. Okay, IP NAT inside interface serial port 0/0/0. So this is my IP NAT outside. Okay, exit. Now I have to give access FN list because all the ports are going to the one single this one. I have to permit a one network, whole network to go through the single router like that. Access FN list. So I'm going to be permitting to one. Okay, there is 192.168.1.0. Okay, wildcard 10.0.0.0.255. Enter. Okay, so next I have to give this one. So IP NAT inside. So inside source list one, that is the permitted list one. I have to give to the interface when they're going outside. They have to give the interface serial port 0/0/0 overload. Okay, so overload is a command. Okay, it's a key that enables PAT, allowing multiple inside private IP address to share a single outside public IP address. Okay, so enter. Okay, exit. Okay, okay. Now let me do one thing. Let me set a packet from here to here. First one will be this one. Oh, it's successful. From here to here, it's successful. And from here to here, it's successful. So let me go here and check what is the IP to stick. Show IP NAT translation. See, my 1.1.1.2, my local, it's taking the port number 1, but inside when it is going, outside is going like 1.2.3.1 using 1024 port, the same IP, but different port. The same thing, if 1.2.192.168.1.3 is going outside, it is taking the same IP address but different port number. Okay. When 1.192.168.1.1 is going outside, it's taking the port number different. That is one it is taking. Okay. Same IP address but different ports are going. Got it? 1.3 I am assigning 3. 3.13. Okay, so this is how in the olden days static IP was used. Okay, so any confusions here, guys?